Hello students, in this session we will discuss about trees data structure. So a tree is a non-linear data structure. Here a tree is a set of one or more nodes such that it satisfies some properties like in tree format there is a specially designated node which is treated as root node, and then the remaining nodes are partitioned into n disjoint sets like T1, T2 and so on Tn, which are called subtrees of the root node. Now such a representation is known as tree data structure. The simple thing, one node is treated as root node and the remaining elements are partitioned into subtrees. Now observe this one example for tree data structure. So here A is the root node. For A the subtrees are here, it has 3 subtrees. Okay. Now 3 point of view, different terms are associated. Now it is better to go for the basic terminology of that tree. Now observe, for supporting terms, this one terminology. First one, node. So in tree data structure, every element is represented as a node. Then edge. The connecting link in between any two nodes forms as an edge. So to connect every two nodes, we draw a line. Now this line is treated as edge. So here one basic property, if a tree consists n number of nodes, then the number of connecting edges are n minus 1. This one, path. The sequence of nodes and edges from one node to another node is called as a path in between the two nodes. Okay. This one, parent node and child node. Let it take any edge. The immediate predecessor of the node is called parent node and successor node is treated as child node. Now observe this one. Parent of a node is the immediate predecessor of a node. If predecessor is parent node, then its successors are treated as child nodes. This one, root node. So in a tree data structure, there is a specially designated node which has no parent node. Now such a node is known as root node. This one, leaf node. The node which does not have any child is called a leaf node. So in general, when we draw a tree data structure, here tree structure paths are terminated at leaf nodes. Hence, leaf nodes are also known as terminal nodes. Reverse thing, non-leaf node. A node which has children nodes is called a non-leaf node. Here, non-leaf nodes are also known as non-terminal nodes. This one, level. Level refers to rank of hierarchy. So when we draw a tree data structure, here the tree is drawn level by level. In general, the root node is placed at level 1, its children are at level 2, their children are at level 3 and so on. So here one general property, if a node is available at level k, its children are at level k plus 1. Then degree of a node. The number of subtrees of a node is called its degree. Number of subtrees of a node is called its degree. So let me take any leaf node. For leaf node, child nodes are not available. Hence, degree of a leaf node is 0. Next one, degree of a tree. So the maximum degree of nodes is called degree of the tree. So to identify degree of a tree, first we indicate degree of every node. From this we take maximum value which refers to degree of a tree. Next one, height of a tree. So maximum number of nodes which is possible in a path from starting root node to leaf node is called height of a tree. So in tree data structure, different paths are available. So indicate which is the longest path. So here the number of nodes available in this path is called its height. So height of a tree is also referred as depth. Okay. Now siblings. So nodes which have same parent are called siblings. So these are the different terms which are associated with tree data structure. Then we go for how to represent a tree. So representations of trees. In general, a tree can be represented in 3 ways, like list representation, left child right sibling representation, and degree 2 representation. Now here first one, list representation, is a simple thing. In this format, first we place root node followed by list of subtrees of the specified node. So here first we specify root node followed by subtrees. Okay. Now observe this example. Now is a tree data structure. Here A is the root node which follows the child nodes B, C, D. B also has 2 child nodes E and F. For F there are 2 child nodes H and I. For C there is a child node G. Now based on this entire structure, now in list representation we indicate like A followed by B followed by E comma F followed by H comma I. So B point of view, the subtrees are completed, comma. Now A point of view, another subtree starts with C of G, comma, third subtree D. Now it shows list representation of a tree data structure. Second one, left child right sibling representation. So in this format we specify node structures. Here in node structure it consists 3 parts. One is data part, second one left child, and third one right sibling. So in this format every node has at most one left child and one closest right sibling. So those links are connected by placing those data parts. Here, now observe this example. So for this, now left child right sibling representation is, now observe, A is the root node. So we place A. For this, its left child is B. So left child B, and for B we need to specify the closest right sibling. Here the closest right sibling is C. Hence C connected to B. For B point of view, its left child is A. Left child A. For A, the closest right sibling is F. So this one E to F. For F, left child H. So F to H. For H, the closest right sibling is I. So H to I. Now, for C point of view, left child placed as G. For C, right sibling is D. So C to D. So this one, left child, right sibling representation. Third format, degree 2 representation. So in this format, simply rotate left child right sibling representation by 45 degrees in clockwise direction. So when this format arises, now it generates degree 2 representation. So degree represents maximum number of child nodes. Hence, in this format, let me take any node. It has maximum 2 children nodes. So from this, we can simply refer as those children's left and right children's. Let us example. For this, degree 2 representation is A to B. For B, left child is E, right child is C. For E, right child is F. For C, left child G, right child D. For F, left child H. For H, right child is I. So these are the 3 possible representations of a tree data structure. Thank you one and all.